Welcome everyone. Today we have another new episode, and this is our 282 episodes, and we have our famous speakers, Professor Edward, Professor Davids, Professor Rob. Hopefully it will be very interesting, and by this way we can learn how we can develop smart manufacturing. This is very important. So I want to start from Professor Edwards. What's your analysis on smart manufacturing? And we are moving forward with this industry 4.0. So how different kind of organization get involved with this smart manufacturing process?
Well, thank you for a very interesting topic here. And this fits in with a lot of the other things that we have discussed in the past. Um, uh, Give you a little bit of context, because that's one of the things I think I do best, is manufacturing, of course, is the production usually of either material things or in many cases material things that are going to feed into services. And one of the things that, of course, has defined the Industrial Revolution is revolution in manufacturing, how we make things. 200 years ago, it was just the process of introducing machines. If you had a workshop where 10 women were sewing shirts, and maybe every day they could each produce 10 shirts, well, then you put a machine into the workshop, and now they can produce 100 shirts per day each. But then what happened, the big breakthrough, of course, was Henry Ford in the early part of the 20th century. And what Ford did was build upon insights of others. That is to say, he made manufacturing a process that he broke down the manufacturing process and looked at what each little step was, in this case, producing automobiles. So he had the idea of standardizing parts so that, every carburetor will fit into, will work with every other carburetor. The idea of an assembly line where the chassis goes down the assembly line, and at some point they put part of the body on, and then another point they put the engine in, and another point they put parts that connect to the engine in, and you do that in a process. And that manufacturing process was able to bring down the costs of producing an automobile to the point where middle-class people in the United States, the emerging middle class, could actually purchase them. And that was his big revolution. And he actually paid more than was the prevailing wage, because he needed workers who would actually stay on the job and do it. It was not exactly an exciting job if all you're doing every day is turning this particular screw and so forth. But of course, now as we're in the 21st century, and with the technology we have, this process is being revolutionized earlier. I've toured auto manufacturing factories back in the 80s, and I was watching the robots that were putting things together. But it's getting even more sophisticated than that, because the manufacturing process concerns lots of elements. It's basically monitoring the process to make sure about accuracy and quality. It's what kind of materials are being used. We've had discussion of material science, and that's a very important one, that where an entrepreneur in manufacturing can say, well, we've been doing this all along with say aluminum, but you know what? We can even do it better with some other nano product, for example. In terms of even eliminating the need for some of the physical items. I mean, that's one of the great insights of producing a smartphone, is that instead of having to carry around a camera, a radio, and all sorts of devices that would be worth $1 million today, you just put them in one little teeny thing here. So it's all an the manufacturing process, and 3D printing, by the way, I want to mention that especially because 3D printing allows for customized manufacturing of parts, for example, more accurately, to be able to put together a part that might be very expensive otherwise to do. You can 3D print it very easily. As we've mentioned in this show in the past, we can now 3D print a rocket ship, which is pretty incredible. And again, the notion of customization, for example, 3D printing, manufacturing, you might say clothing that fits you exactly. So this is just kind of the context. I'll be interested to hear what my colleagues here are saying, probably some of the stuff I could say, but I want to yield the floor to them to fill in some of this really wonderful future that we're looking at with manufacturing in the digital age.
Mhm. Thank you, Professor Edward. Professor David, how do you want to analyze this smart manufacturing and how we can integrate more with IoT, AI, blockchain technology, these modern things? I think this is the demand right now, even COVID-19 situation.
Well, you hit the nail on the head with the comments there. Is manufacturing has changed so very much over the last decade, and both from a technology standpoint, and it's also changing from a geopolitical standpoint right now as well. Everyone knows that robotics have made a major impact in manufacturing, and we're seeing that continuing, particularly with the proliferation of lower cost robots and robots applied to 3D printing and 3D manufacturing, but also the amount of sensors entering into advanced manufacturing has dramatically peaked. And we're going to see that trend continue with not just external sensors, but sensors embedded into the products that are being manufactured and will continue to be in that product for a role both during the manufacturing process and during the life of the product, so it can be used to monitor, enhance, and in some ways even change some of the feature functionality of what's being manufactured after it leaves the factory floor. With this type of technology innovation, technology advancement, the smart manufacturing floor has been connected. It's connected to their in-house internet. It's connected in many instances to the external internet, particularly since suppliers are in many instances controlling the technology inside the company that's doing the manufacturing itself. So you've opened up your advanced manufacturing environment to a much wider system than it has been before. And with that comes efficiencies, particularly since the manufacturer of the manufacturing device has more expertise. But it also opens you up to cybersecurity risks and other things like that. So one of the very interesting things in advanced manufacturing is it's changing, and it's changing a lot. And we're in a fairly steep curve now with that. But then the geopolitical part comes in today. And some of the things COVID taught us is it's probably better to have multiple smaller factories in multiple geographic locations around the world than one mega factory in one location that is much more subject to disruption. And so to me, those are kind of what I frame advanced manufacturing in today.
Mm-hmm. Thank you, Professor. Professor Rob, how do you want to analyze smart manufacturing and how you want analyze more on Industry 4.0? Because this is the basic things I think we have to implement right now.
Right. As well, smart manufacturing is the process whereby you create a structure that is adaptive to the needs of the customer, the materials you have available, the employees you have available to you, and that structure is able to automatically modify itself depending on those changing variables. It's kind of the ability to solve existing and future problems via an open infrastructure that allows solutions to be implemented at the speed of business while creating advantage and value. It's kind of our path to turning factories into big 3D printers. Lots of automation, lots of sensors, but really the goal is to create a very agile system that can adapt to the changes and the changes that surrounded in the ecosystem that surrounds it. It has elements of supply chain components that are being applied to it, as others have mentioned, or things like blockchain to assure supply chain, but also large degrees of computer modeling, the digital cloning that or digital twins, I think is the right term, that is coming forward, where you create a digital model, a virtual model of the factory, and then you test on the virtual model before you apply it to the physical model. But it is highly computerized, increasingly uses artificial intelligence, and the goal is to make it very adaptable, very flexible. So whatever the plant is, it's optimally used regardless of the product that's being produced in it, and it's able to switch its output depending on the changing variable. So as I say, it's on the path of turning a factory into a big 3D printer, where at some point you'll put materials in one side, finished products will come out the other, and those finished products could be defined real time by the customers that specify them. So this is a major sea change, and we've been talking about this as part of the fourth industrial revolution. This high level of automation, this high level of flexibility, and this heavy application of artificial intelligence.
Mm-hmm. Thank you, sir. When we're discussing about smart manufacturing, I want to start from Professor Edward. Like when we're discussing on smart manufacturing, even Asia Pacific has huge population. Do you think when the industry from Asia Pacific, even China has heavy manufacturing, Malaysia also have a very good manufacturing, Singapore, they are also adopting all of the modern technology. What do you think? Like smart manufacturing means we have to reduce more employees, we have to adjust with more robots, more AI, and it will create some efficiencies of the manufacturing, or what do you think as a policymaker? Yeah.
Yes. Well, you're asking exactly the right question, and it's the same question as being asked in industrial countries and certainly in the United States. And interestingly enough, it's across the political spectrum in the United States. It's not just a matter of the left wing or the right wing. There is this. I'll address that part first. There is this fear that goes back literally to the beginning of the Industrial Revolution, that the more manufacturing becomes efficient, the more you're going to have unemployment and displacement. I mentioned at the beginning of the discussion, if you have a workshop and you have 10 women, they're sewing shirts by hand, and they can each sew 10 a day. You put a machine in there, they can produce 100 a day. Well, you can probably cut 5 of those employees because you're producing 5,000 shirts a day, even with 5 employees. And that's all the market's going to take. If you produce 10,000, you're not going to sell your shirts, right? So don't you have unemployment? Well, no. What happens historically is that the price of the manufactured good goes down. So instead of having to spend, say, a month's worth of income for a poor person in England to buy a shirt, now it's maybe a week's worth of income or a day's worth of income. But what that means is the profit margins go down, and then investors who are making the profits, from the manufacturing say, well, gee, where can we take this money and put it? Let's produce something else. And so then they create a workshop or a factory or whatever to produce other things. That's exactly what's happened, and that's what's created the middle class over the past 200 years. But here's the key. First of all, with exponential technology, the change is happening very, very rapidly. We don't have a few decades or even centuries for labor forces to adapt. It's very, very quick, and we need to have an innovative system that allows workers to keep up their skills, to retrain, to be flexible. We've had discussions on this show about the importance of flexibility, importance of when you train yourself, don't just train yourself for some very, very narrow task, because there's a good chance that task is not going to be there. But if you're more flexible, you can take your skills from one task and use it for another. The other thing is this. The change is going to be lumpy, as we would like to say. In other words, some industries are going to change very, very quickly. Others, it'll be a little bit slower. And so you're not going to have, even with exponential technology so fast, you're not going to have people thrown out of work en masse overnight. There will be time to adapt. But I think it's important for workers to change their consciousness, so to speak, and think of themselves as entrepreneurs. They're the entrepreneurs of their own lives. I think it's important as emerging economies develop education systems and that will serve the people. That these education systems not only focus on training them in some particular skill and certainly basics, but training them to think of themselves as entrepreneurs in the workforce. And of course, it's very important. I'm literally writing a piece right now that I owe somebody about this whole topic. It's important for entrepreneurs to understand what's happening in the future about the industrial revolution or manufacturing 4.0. It's important for entrepreneurs to understand that. Otherwise, they're going to be stuck with the successes of the past, while more innovative companies and individuals are producing the industries and the goods and services of the future, and they're going to be left behind. And so you're going to even have more sudden unemployment because they're not focusing on the future and not allowing their industries and their companies to adopt to the new reality.
Mm-hmm. Thank you. Professor David, you are also a professor for a university and you are also deputy dean. My question is that when like you develop your curriculums or you are producing your human resources from this academia, how you actually make the bridging in between, like make relations in between industries as well as academy, and how it works, what is the scenario, what's happening inside?
You always come up with the best questions. That is one of the keys, I think, to making advanced manufacturing happen. A good example is in the United States, we put together a consortia called Sematech to recover the computer industry. I was one of the first 7 people there on the startup team and an executive there. It was decided to locate in Austin and really advance the semiconductor industry tremendously. It looks like the next big Samsung fab is going to end up being selected for Austin, which is a $17 billion manufacturing facility. But what we did when we formed Sematech is we did a public-private partnership, and we went to Austin Community College. We went to the University of Texas at Austin. We went to other universities in the area, and we set up training programs in the community colleges to produce technicians to support the fab, to work with that. We went to the University of Texas and we set up scholarships and endowed professorships to advance the science that we needed for advanced semiconductor manufacturing. We went to others like Southwest Texas State, which is just south of Austin, to set up management type of programs that are needed for advanced manufacturing, because they're all very different. But what you're going to see, particularly with the pace of change today, is that the education models have to change. We're really in a time of lifelong learning. And we're increasingly going to a concept that's used in advanced manufacturing a lot, and we're beginning to pull it over to education now too. In manufacturing, you have just-in-time delivery of the supplies coming into the manufacturing process. Well, what we're increasingly seeing is just-in-time delivery of the education, of the training, of the skills that are needed to work as the manufacturing floor changes, as the manufacturing environment changes. And you see also a big change in the type of skills that are needed. And so some of the people who were on an assembly line doing manual work might be redirected over to be one that interacts with the sensors and adjust the flow from the sensors. You might see some of the same manufacturing people doing the hands-on work going over now, becoming more maintenance technicians and things that work with robotics, that work with the 3D printing. that work with the other elements there. And then of course, the IT side, the development side, the programming side, always going to increase too. One of the other interesting jobs that I think is going to be very in demand is a new type of scheduler, logistic scheduler, who can manage the just-in-time delivery of the materials that advanced manufacturing enables you to do, but also someone who really understands the nuances of how I can optimize production flow, how I can optimize the machine flow through it. And one of the downsides of advanced manufacturing is sometimes your assembly line moves too fast. And a process that you did in step 12 that normally would have a day or two before it gets to step 13 is there in a matter of seconds. And sometimes things don't get to cure, they don't get to finish their process there. And so the ability to schedule that's a very different type of scheduling than a traditional manual manufacturing process flow. So a lot of skills, a lot of education, but the tenet is it's lifelong learning and education, even in software development, is going to the mode of just-in-time delivery of that. I know many of my developers that I use today, they see a new concept, they spend an hour on the internet, and they learn a new skill. And they certify in a new skill overnight. So that just-in-time education is going to be a tenet, not just for advanced manufacturing, but for many parts of our technology-enhanced world.
Thank you, Professor. Professor Rob, we live in a globalization. When COVID come, actually, this globalization come with little bit of different things. Now the concept and everything changing for the globalizations. We are depending on more national economy, more local economy. Example, Malaysia was a tourism country. Now they are more focused on their national tourism, not the global tourism. Anyway, the fact is that developed nation, let's say USA has some sort of dependency with this developing nation production manufacturing. Let's say they have dependency with China, they have dependency with India. Even example for garments industry, they have dependency with Bangladesh or Vietnam or this kind of countries. Do you think when smart manufacturing process come and the first world, they will adapt more automations, more computer robotics and this kind of things, this dependency will not move forward, and they will maximum the productions and everything they will manufacture in their own country like Europe or USA, and by this way like economical model or globalization concept will change in the future?
Well, it's already changed. The pandemic identified huge problems in the supply chain, largely due to the differences in the pandemic's effect on different countries. Some countries became non-viable early. China was one of the first to become non-viable. And as you point out, there were huge dependencies across the world with regard to Chinese manufacturing, which was the cheapest, one of the cheapest at the time. And we lost access to those facilities when China shut down. And the factories that China had were labor intensive. And so they couldn't really be operated remotely. On the other hand, China came out pretty quickly, so they were covered. But as they were recovering, other parts of the world were failing, and now you had a parts supply, but not your major manufacturing plants were down. So right now there is a major effort to think through the supply chain and bring it into control. Companies want to be able to be assured that the parts that they want will be there when they need them, and currently we're facing a rather dire microprocessor shortage. I just finished a series on that yesterday, where the discussion really was a lack of planning, a really bad lack of planning as we went into the pandemic, and computer models that were based on prior events that turned out to be inaccurate. For instance, we thought that the markets were going to crater as we went into the pandemic, and they did go down, but they didn't go down anywhere near as much as we anticipated. And here in the United States, the stimulus efforts caused spikes in demand at a time when the industry had thought that we were going to have these huge valleys of no demand, and so they had lowered their expectations with regard to the number of parts that they would need. They'd abandoned entire lines, and those fabrication plants then shifted over to other industries and products because they had to remain running. I still thought they were going to need parts, and now we're faced with the fact that we don't have the fabrication capacity that we need to build the computers and IoT and appliances that we need. I mean, we just hit a wall on appliances, and it's trickling through. We've already hit automotive, we've hit computers, we're now hitting appliances, and microprocessors are used in pretty much every one of our smart devices all around us, and we can't get them. And the expectation is this won't relieve on the fab side until Q3, and this won't relieve on the finished goods side until 2022, probably in the first half. And really had to do with the fact that there were just a horrible, that we just didn't have good models for what was going to happen during the pandemic. Now, hopefully we do now with regard to pandemic impact, but every pandemic we've had has been a bit different. The global impact's been different, and it makes it very difficult to create viable models that you can rely on. And the result is countries are saying, let's just bring it in-house. Let's bring everything as much as we can. Let's bring the supply chain domestic so we can control it. And then at least if we have an outage, everything's got an outage. It's not part of us is coming back, the other part's going down, that part's coming back, the other part's going down. And so the pain extends over long periods of time. I'm not convinced that's that is a sustainable strategy because regionally, there are efficiencies to be had, and generally cost and price drives a lot of these decisions, and clearly they're not being driven by that now. So we're in kind of a change mode, both from the pandemic and this fourth industrial revolution, and we probably won't be settled until into next decade, and so that means there are going to be a lot of balls up in the air, and we're really not going to be all that sure where they're going to fall yet. As David pointed out, the big thing is going to be permanent retraining. I mean, almost consistent retraining. I will disagree with Edward a little bit in terms of unemployment, because every time we've had one of these things, we typically do get a high wave of unemployment initially as certain jobs become obsolete. And then the ecosystem moderates and that eases. But there has been in the past been up to a decade or more of issues as these things change. And the way you mitigate that is you force training early, and so you make sure that the jobs that you need filled have people to get them, and that the people that are going to be losing their jobs have some place to go into in terms of another career. And then you can mitigate this damage quite a bit. And the good thing is with computer modeling, we can anticipate a lot of this. The thing is the computer modeling is not, to my knowledge, being fed into education, and it's not being fed into the demand side of kids that are looking for the careers they want to have right now. They're not being given the guidance from these models that says this is really where you should be concentrating, not for the jobs of today, but for the job you're probably going to have in 5 years when you finish education. That's really where it's kind of broken right now. It very much, the educational paths that people are on have remained to a large extent unchanged, and they should be changing dramatically in anticipation of these major events in manufacturing and in pandemic response. So things aren't where I would like them to be, but we have the tools to fix them.
Thank you, Professor David, then Professor Edward.
Rob,
Yes,
I love what you said. One of the universities, one of the colleges around here, State Technical Institute, actually employs futurists as part of the administration. And they every year go back and do a refresh on what are the new industries that are coming, what are the changes in the industry, and what are the new skill sets. And I find that is very interesting. But the other key to something you said, Rob, is I mentioned the public-private partnerships before, where academia, the private sector, and the government work together. That is one of the ways to mediate the rapid fall of the outdated jobs and to help you take that curve and compress it to where you have people beginning to train before they're even let go of their old outdated job into new skills things. And it's a simultaneous process. We're in a time where you can work and learn at the same time.
Yep.
Yeah, I have many of my folks taking classes at night or going to boot camps at night after work because they're positioning themselves for the next change. And if I'm in a community where I have the interest in areas that are impacted by this rapid technology change, I would highly encourage them to adapt more of that blended approach to learning where you continue to do it, and that is where they'll get the air advantage.
Sadly, though, I think it's still the exception rather than the rule, and it should be the rule rather than the exception.
100%.
We have the capability to do very detailed, advanced models, and that should be feeding back. And the screwy thing is these systems exist on many of the larger college and university campuses, and they should be being used to do a better job to help their students find their paths as opposed to just exploring things like weather and space exploration. Anyway, my opinion.
Yeah.
Thank you, Professor Edward. Yes.
Yeah, actually, I don't think I disagree with Rob so much because back in the early 90s, for example, maybe even earlier than that, one of the things I was working on was trade adjustment assistance. And that's the idea that as we became a freer trade country, which I strongly support, that certain jobs were going to be displaced. Again, as for example, now we get more clothing and garments from Bangladesh and Vietnam and so forth. Well, factories in South Carolina and North Carolina are going to have reductions in employment. And so you do have these spikes. And one of the complaints that I had even back that far, and now you see it's even more important today, was that we don't have a system in this country, and this I'm talking about the United States, but you can look at other countries as well, where you allow workers to anticipate that this sort of thing might happen. We have a system in this country where if the government takes money out of your paycheck, and then if you lose your job, they give you a certain amount of money per week, until you can get a new job, and there are various ways this is done because there's a state approach as well. But the point is, they wait for you to lose your job before any of the benefits kick in. And I was advocating even back then that you have some kind of a system where, for example, some of that money would go into a subscription to retrain or other approaches where you'd be able to move quickly to another job because you're retraining all along, or maybe if you have a month or two of unemployment, then you could be training during that time and not just sitting at home trying to find a new job. And those sorts of systems now are even more important. I completely agree about lifelong learning. I sometimes hold up this book about robot proofing. There's other great work that's being done in this area, and this points out the importance of integrating education reform and the future economy. These things are not disconnected, and unfortunately in the public policy area and in most governments, they're disconnected. You have a Department of Education over here, and then you have a Department of Commerce over here, and a Department of this over there, and they're not really integrated. I want to make one other quick comment because this issue came up, and that is that we are in this weird balancing situation where globalization in the sense of economics is good. It means that we can get manufactured products that are produced at a less cost from Bangladesh and India and places like that in the United States. Therefore, we in the United States can concentrate on other things. That's division of labor. That goes back to Adam Smith. And it's one of the reasons why we have our incredibly prosperous world today. And of course, the pandemic has pointed out the problems of having your manufacturing chain, your supply chain all over the world. Right now, Apple is negotiating with China about the future arrangements, and there are a lot of issues involved. Part of it is, to what extent does Apple want to rely so much on China because of what happened with the pandemic? There are geopolitical issues as well. There's correct criticism of the prison camps that China maintains about their human rights violations, things like that. So there's an issue there. It's a very complicated issue. I'd rather see an integrated economic world, but we are going to probably be kind of coming up with a balance of what is going to be done locally, how much you're going to be relying on a particular country versus, many sources for your inputs and so forth. And all of this, by the way, points to the manufacturing 4.0, where so much of it is going to be in the factory with, again, as Rob said, the factories will become great big 3D printers.
Mm-hmm. Mm-hmm. Thank you, Professor David. We bring very important point, especially skill developments of the youth communities for survive in this industry, manufacturing industry, and whatever it is. And second things, this is my personal opinion when we discuss about public-private partnerships, because as a consultant and consulting company, we have engagement with different developing nations, and we saw that yes, sometimes government has more incentive, more opportunities for this kind of project, but success rate, if we think this public-private partnership, I think we need to move forward. We need to make different strategy. What is your advice in that particular area for developing nations from Asia?
Well, the role of the government sometimes is just one of being a bulldozer and cleaning up the road so that the companies and academia can move together faster. Mm-hmm. Mm-hmm. And help eliminate some of the roadblocks. Sometimes it might be some initial seed funding, particularly if there's a lead lag time in developing the capabilities you need for the human capital before they can be installed on the factory floor. Mm-hmm. And so there's many different roles. And I can tell you, back with the example I talked about earlier, Cimitech, what the local government in Austin did is they took the building process for building the advanced fab, and they had inspectors on site. Mm-hmm. Mm-hmm. Instead of taking weeks to schedule that and come in, they took the approval process and cut it by 90%. Mm-hmm. And to be able to do that. And they let us go into not just places like the University of Texas and establish endowments for professors there and chairs for professors there, but also new scholarships to sponsor students. Mm-hmm. And so there's a lot of different roles in there, but public-private partnerships have many different forms. Mm-hmm. It's just like if you try to do a roadmap in this domain, there's multiple types of roadmaps. There's technology roadmaps, there's services roadmaps, there's capability roadmaps. And a capability roadmap helps you understand what are the human capabilities that are needed. What are the other logistic capabilities that might be needed beyond the technology and beyond the services you're trying to do? Mm-hmm. And so there's a lot of ways to begin to address this going forward too. But for developing nations, it's really critical that they look out the windshield of the car where they're going, particularly around advanced manufacturing, as opposed to just primarily looking in the rearview mirror. Mm-hmm. There's a reason why our rearview mirror is smaller than the windshield. You want to learn from the past, but you really have to do a better job of looking out towards the future, particularly when things like manufacturing is moving as fast as it is, how retraining is moving as fast as it is. And you've got to have that future mindset.
Thank you. Professor Rob, as you are a great strategist, especially for this corporation and the big corporation from USA, even though the Asia Pacific or different developing nations, they have their own economic sustainable model. But when we think that definitely we have to adjust with this smart manufacturing approach, we do not have any choice. And in that situation, we are observing many corporations, many manufacturing company, they do not have enough preparations. What is your guidelines for this kind of company? Let's say 60% of the corporation, like manufacturing company, they do not have enough preparation for this smart manufacturing. How they can improve?
Well, they have to understand whatever their customer needs are. I mean, they're supplying parts to somebody right now. The discussion then starts with whoever they're supplying the parts, components, whatever services they're supplying first. Because it's going to vary industry to industry, part to part, and what you want to do is make sure that your systems will integrate with your customer systems as they automate. Smart manufacturing really has to do with automating and connecting as many components in the manufacturing supply line as you possibly can. The old terms will think like just-in-time manufacturing and the rest are a little antiquated now, but the concept is still there. You don't want to have excess inventories. You want stuff to arrive when you need it. You want to minimize waste. You want to increase automation and reduce the chances of disruption from things like pandemics. And that does require a consistent method of monitoring, of quality control, of instrumentation, so that the recipient of the parts can monitor the process from cradle to grave as much as possible. And as I said, with things like digital twins, now we're moving to a case where we're creating these big virtual models of the factory and of the ecosystem, and these subservient factories have to be able to plug into this. If they can't, they're probably not going to win the bid, and so increasingly they'll be on the periphery, working with older clients that have not yet updated their infrastructure, because the folks that have updated their infrastructure, they won't be able to plug in by policy or systems to their control structure, and they won't be able to play. And so this is a case where you either update and adjust, or you find another business to be in, because your customers are going to move to where the support structure exists for the systems they want to put in place. And as David pointed out, that this takes a while to do. You don't want to start it when you recognize the problem is current, because then it's too late. You want to arrive at this level of advancement at the same time your customer needs it or close to it, so that you retain those customers. It's far harder to get a customer than it is to retain one. And so if you focus on retention and making sure that you are well connected to the customer's needs, not only today, but their anticipated needs over the next 5 or 10 years, you'll probably be in pretty good shape. But if you're treating this business as normal and that things aren't going to change, you're probably going to find out that customer is going to move to somebody that can better support them, because they have to. The audit risk alone will simply be too high. And as we move to automated auditing, your inability to plug into the systems will mean you'll be non-compliant on day one. So it's really thinking ahead and making sure you retain the capability of being compliant with the supply chain rules that govern the customers that you serve.
Thank you. Professor Edward, there are a few questions from audience. I want to take one question for you. Ahmed, thank you for your question. What groundwork needs before going for smart manufacturing?
Well, certainly in the emerging economies, I mean, obviously in places like the United States, Singapore, and South Korea, and some of the other areas, they already have the groundwork, because they're major manufacturers already. Samsung, we mentioned earlier, I think, is setting up some more operations in the Austin area, and people who don't have Apple phones have Samsung phones. But in the emerging economies, to set up the groundwork, so to speak, I would concur with my colleagues here on the importance of education. You don't want to sort of just rush in and say, well, look, everyone else is doing this in the West, so let's quickly get some money together and some capital together, and let's create something that looks kind of like what they're doing. Because what we're doing today in any particular manufacturing facility or area, may be very different in the future for all the reasons you've heard in this discussion. I would say the most important thing is education. The most important thing is the kind of partnerships, for example, that David was talking about. That companies that, for example, Cementech did in Texas, where they were partnering with junior colleges and with other facilities. And by the way, Silicon Valley had a lot of that sort of cross-fertilization, we like to say. So what I would say is focus especially on the education system, the training system in the emerging economies, because that's going to bring you the most bang for the buck in the future, and it's going to set the, and again, especially if you inculcate young people with the notion that they are entrepreneurs of their own skills, they're entrepreneurs of their own lives, their own priorities, and of course they ideally will be entrepreneurs in the market, always keeping an eye on the customer, always keeping an eye on, well, what customers might need that they don't even know what they need. Of course, the classic example was Steve Jobs, who basically said, most people don't know that they need a personal computer. I'm going to show them that they need one. And of course, that's what happened. So I would say that if you want to look at the foundations for manufacturing in the future, focus on education and the kind of diverse approaches that David and Rob have quite correctly highlighted.
Thank you. Professor David, I want to take another question from audience. Onika Shams, how the industry will be benefited from smart manufacturing?
One of the biggest benefits of smart manufacturing is it becomes more adaptable. It becomes where you can change your processes a lot faster, and you can incorporate new things in it, or you can actually take a manufacturing facility and move it to other even product lines, other industries even. One of the things that we've seen in the semiconductor factories is that the older ones that can no longer generate chips that work with today's geometries, is they're being moved to other things. There's multiple old semiconductor fabs that are now doing biological processing in it and building biological chips. You're seeing them move to nanotechnology and developing structures to use with that. And so it's not just smart manufacturing can really enable you to do more diverse type of manufacturing in the product areas that factory was originally designed to manufacture in, but it transitions over to other new industries much more rapidly.
Thank you, Professor. There is another question from audience. I want to Nur Fazrin, for Professor Rob. What skill set are needed for smart manufacturing? I think they have love to learn that how can they develop their skill set.
Well, okay, so it varied. I mean, a smart manufacturing environment is relatively diverse in terms of skills. I mean, you still have people that need to be able to repair the equipment that's in place. Initially, you need some ability to create models, computer models. You need an understanding of manufacturing technology. You need to know supply chain. You need to understand quality control, and how it's and what automated tools and technologies are available for that. You need to understand advanced computer modeling, both in terms of assessing the factory you're planning to build and in terms of creating these digital twins to emulate the factory once it is built. You need a broad set of experts, but where you're typically lacking are going to be in the computer modeling skills that aren't known to exist very deeply in traditional manufacturing environments. That's probably where the biggest gap is. And here's an area where you probably are going to need to partner to get the skills, because you probably don't have the skills to know what skills you need. And so going to a partner that's farther down that path and has already learned these lessons can provide you with the advice and counsel you need for your particular industry, and recognize that it is very industry specific. What you need in terms of skills and capabilities for manufacturing consumer goods is going to be very different than if you're manufacturing heavy equipment. But some things may be the same. Some of the process nodes and control structure may actually be the same, just it's applied differently. And so this is not something you want to learn by doing. This is something where you want to locate people that have already experienced some of this stuff and have gone through the expense of making the mistakes the companies make as they're ramping up and changing environments, and then learn from their mistakes as opposed to your own. That can speed up the process quite a bit and lower your overall cost of conversion substantially.
Thank you. I want to start from Professor Edward, but I want this answer from all of our speakers. Basically, if we move with this policy making for smart manufacturing, because developing nations, when they develop this policy for smart manufacturing and this kind of things, they have to think in two ways. Number one, their local ecosystem, as well as the foreign company, the big corporation, those who want to shift their manufacturing hub in developing nation or in Asia. So what will be the best approach for developing the policy if we want to advise to the governments from to the Asia?
Mm-hmm. Well, I'd add a couple of things. I have mixed feelings about public-private partnerships, and I've actually advocated in some cases for the efficiencies of them. And I also understand that a lot of times you get inefficiencies because what starts out as something that's going to help everybody ends up becoming vested interests where something is not working, but for political reasons they keep getting support and it keeps out other competitors. So I would say to the government a couple of things. Focus on only where you really need to have the government involved. Okay, if it's for some, again, especially for things like infrastructure, and infrastructure defined in a narrow way, not in the way that we're doing it in the United States today. I would say that I've heard it was David or Rob pointed out that a lot of times what governments can do is they can get rid of a lot of the barriers and blocks to innovation and to the sort of dynamic systems that we need to develop. In the United States, we have some examples of where, for example, we have a natural disaster, like I remember in California, it was an earthquake, and they were able to rebuild some major highways and infrastructure, very, very quickly, because the state government basically came in and said, okay, we're going to essentially short circuit all of the long process of getting regulatory approval, et cetera, et cetera. We're just going to let you go in and build. And it worked out very well. And that's one of the issues that we're dealing with literally right now with our Food and Drug Administration. Just essentially saying, look, there's a lot of stuff in the way that keeps, that gets in the way of this development. The other thing in terms, because you asked about the global issue about whether you should do it in Malaysia or in Bangladesh or in India or wherever versus overseas. And that's going to be something that really the market is going to help determine. I think we're going to keep a globally integrated economy. I can't see any way of getting away from that. And I don't want to get away from that. And so I think there's going to be a market niche, but I think the government should keep in mind to make the country as business friendly as possible to for example, foreign investors. And then hopefully what they'll do is come in and say, well, we could really benefit if we have a new facility here in Bangladesh or here in Malaysia or in Indonesia for that matter, and so forth. So keep it as friendly as possible. Be very careful about corruption. I studied a lot about the Indian system, the system in India versus some of the other countries. And one of the reasons a lot of investment didn't go into India is because the system was so bad that investors have said it's not worth it. The labor costs are low, but it's not worth it going in there. And what you see is a lot of what India provides now are things that, for example, call centers, things where you can do it remotely, where you kind of go around the process of if you're building a facility in India. So I'd say be careful about that as well. By the way, just one other quick thing I want to mention is from the discussion is the importance of integrative systems is really crucial, and it's crucial within a facility, and it's going to be crucial in terms of kind of the global situation of, because a lot of entrepreneurs are going to be thinking about an integrative system, and to what extent does putting some operation in Indonesia or Malaysia help our business as an integrated system. I remember a discussion I had with a gentleman named John Young, who was Apollo 16, one of the moonwalkers on Apollo 16. He was an astronaut, and he had been tasked with looking at the systems integration of the space station. And I remember discussing with him about that, and he was going over all of these problems, just integrating all the parts of the International Space Station. So I'm very conscious of the importance of systems integration, and it's even more important when you have a very fast-changing technological environment like we do today.
Thank you. Professor David, I'm coming to you. Before that, I want to give chance to Professor Rob, because I think he will leave early. So yes, then I come back to you, because I know you are expert on policy. Professor Rob.
Well, if I were setting up something, I would start with advanced modeling. Often the issue with regard to government looking at manufacturing capacity is they throw money at the problem with incentives, and they don't think through whether the factory actually has an long-term economic advantage to be in country. And so you need to first assess what your regional advantages are, what your logistics advantages are, what your supply advantages are, and then pick industries that best map to what those advantages are. If you've got really cheap labor, then you're looking at things that are going to make use of really cheap labor. If you've got access to some minerals that are scarce elsewhere, then you want to look at manufacturing capabilities that use those minerals and capabilities. What you don't want to do is you don't want to spend a ton of money in incentives to build a factory that is not optimally located in your location, because what's going to happen when those incentives run out is that factory is going to fail, because it won't be competitive. And so it's critical now, since we've got the capability to start with modeling and simulation, so you understand what types of business will work best, what types of factories and manufacturing will work best in your region. And then once it's up and running, you have a better chance of sustaining it. You don't have the kinds of things that we've had in places like Ireland where they incent the heck out of a capability. It goes for a few years, then it fails catastrophically, and you now have another large empty manufacturing site that nobody wants to use. That's not. It's great short term for political points, but long term is disastrous for the community in the area. So you really do need to think strategically and use computer modeling and simulation to best place the things that you need in your region that can be competitively advantageous, and then around that you can decide on skill training, capability, enhancements in transportation, all the other things you need to secure that beachhead. But if you don't start off first about thinking about what's optimally available for your location, then you're going to fail regardless of how much money you point to it. And then I've got to run.
Thank you, Professor Rob. Professor David, what is your advice for the policymaking and this?
I think the other two are exactly right, in that you've got to do those different elements, and public-private partnerships are not the solution for everything. But in many instances, particularly where there is a technology growth for a region, they're very useful because it helps jumpstart that process, where industry by itself has a hard time doing that. And it gives you a more rapidly raising water level. But the other thing that I want to say is, if I'm in an area where you're developing, you build locally, you pull regionally, but you have to think globally. And that's an important policy thing. I've got to have the capabilities to build the advanced manufacturing facility. Oh, but I also need the infrastructure. I need the electricity. I need the water. I need the transportation infrastructure. But I also know I'm going to regionally go outside my locale to do that, is I go and use more services, like the maintenance services to maintain the advanced manufacturing equipment and stuff. In many instances goes beyond the local side. But one of the neat things about our age is outside the personal service industry, most businesses are global at launch. Because one of the first things we do is we put up a website. And I can be sourced globally that way. So you've got to think that way as well. And just to give you an example, not far from my house here, one of Elon Musk's Tesla gigafactories is going up. Amazingly fast. Amazingly fast. How did he move as fast as he is? It actually was a partnership with the government regulatories around him. Multiple cities, multiple counties. And he's now purchased more land, and we're going to have our first rocket manufacturing facility and satellite manufacturing facility next door to the Gigafactory. Oh, and across on the other side of the toll road that goes through there, they're building a thing for neural implants. That all of those are advanced manufacturing, all with very different ways to look at it. And industry can feed itself. Now, what's interesting with those three is as they are working with the academic institutions, they're putting plans around in place for training that can support all three of those. And the Austin Community College Foundation is going to build a training facility right near that group, because that particular manufacturing operation is going to employ over 10,000 people. So it is also point of use building to support high growth areas of advanced manufacturing. So from a policy standpoint, you have to go back and say, my models have to change. My modeling, as Rob said, has to adapt. And what is really good is Austin was a leader in the United States on consortia and was home to some of the largest consortia. And I was an advisor to the Advanced Manufacturing Consortia as well. And you have to, on a policy side, adapt more to rapid change. You know, you know, if I'm building a semiconductor manufacturing fab, my life cycle of the equipment in it is usually only 2 or 3 generations max of a chip, because the lines get smaller, the geometry changes, the processes change, how I image on it changes. And you've got to design to be able to throw those out. Well, a policy statement is many times the local governments are taxing that equipment. And they're going in and say, I'm going to tax you like an old style manufacturing plant, where the economic life of that manufacturing tool is 20, 30 years. Many times in advanced smart manufacturing, the economic life cycle of a tool is less than 10 years. So from a policy standpoint, you need to set policies in place that understand, even in things like taxation, even in things like depreciation. It's a different world with different care abouts that need to be addressed. And policy is a slow thing to change, but manufacturing is fast to change. So you have to blend those together more than you have in the past.
David, by the way, is very correct on this, and maybe I can put it together in the notion of communities of institutions, or if you want to talk about public policy, enterprise zones. If you take a look at Silicon Valley, one of the reasons why it's one of the great hubs of technological innovation is that they have Stanford University there. They have various education facilities there. They have, in a sense, they have all these institutions that can help one another. People will often start in one company, go to another company, start new businesses there. It's like it's an incubator for creativity. You have there's a book by, I think it's Kai-Fu Lee, AI Superpowers, that I recommend to everybody. And he was a Taiwanese American who has worked, and I think still works, in China. He was I think he was the head of Amazon or Google in China. I think it's Google in China and so forth, an investor. And he discusses what China did in terms of creating what I would call a kind of enterprise zone. And so it involved government providing certain kinds of infrastructure and so forth. But it was really the fact that you had kind of an incubator where different companies and different education facilities would set up, and they would all work with one another and support one another. And it was a very dynamic situation, just as in Silicon Valley. And you now see this, it's been emerging in Texas for quite a while. And now you see, especially because companies are shy about going to California for many, many reasons, you see Texas emerging even more. So if I were in Malaysia, if I were in Indonesia and so forth, I would suggest looking at that kind of model, because yes, one particular facility, in 10 years might not be, that profitable or that innovative. But if you have a lot of facilities around, there's going to be a lot of this cross-fertilization. And especially, again, young people who get the proper education will be involved in that, and they'll be seeing how to change quickly with the dynamic situation.
Mm-hmm. Mm-hmm. Yes.
One thing to build up on what Edward said, one of the things Stanford does exceptionally well is there's a professor out there who she and I are fellows together on a couple of things, Martha Smiley. And she runs an activity with a really unique focus. A couple of years ago, one of her focuses was the future of work, and I was the keynote speaker on it. But what they did differently is they brought an international group together for 4 days, and we presented about what we thought the future of work was. Then we went away. Mm-hmm. And we went away for about a month, but continued an electronic dialogue. But then we came back together for a couple of days, and it wasn't about learning from each other. It was more about, with the future of work, now what do you have to do to be effective on it? And so even the way universities and colleges and things work together will change some too. I find that particular Stanford model that she uses extremely effective, because most of the meetings I go to, you go for several days and you talk about it, but you leave out the now what part. Mm-hmm. And that's a model which I think is very effective and can be done. Mm-hmm. The other thing that I think is very effective, and Stanford did this early in Silicon Valley, the University of Texas has done this early in Silicon Hills, mm-hmm. is we involve putting students and graduate students out into that world. One of my areas that I've done a lot of work in is technology transfer. Mm-hmm. And, I can use the analogy, it's really hard to push a road, it's easier to pull it as you look at things. But what I really believe in is I pull people's legs and ask them what's the best vehicle for transferring technology and for bringing new technology in. And we have great discussions. I go back and say, no, guys, the best way to transfer technology is a moving van. Mm-hmm. And when you move people, that's when you have the greatest way to advance what you're trying to do. So take a graduate student and move them into that manufacturing process.
Mhm.
Let a professor sponsor different dissertations in the area you're moving that advanced manufacturing facility into, the new science areas that are needed for that. And again, think about moving people more than just doing the studying.
Mhm.
Yeah. By the way, David, this, one of the things that is, you probably know, Switzerland does very well, and some other countries, is
We do.
apprenticeships. Switzerland, 70% of kids in Switzerland go through some sort of an apprenticeship, which is essentially it's a tryout for a job. But again, it gets them early on, sitting, part of their day, and working at a pharmaceutical facility, a financial institution, or a tech facility, or something like that. And so you're kind of getting that learn and earn approach, and that notion that I'm an entrepreneur and I'm trying to figure out what's the best way to move ahead, and I'm understanding the importance of learning on the job and and that kind of education, and not just sitting in a classroom and listening to Ed Hudgens lecture me. And so I think the Stanford approach you've talked about is interesting, because I've done a lot of stuff recently on medical issues and future medicine. And one of the things I tend to do is, after a week or two of having, 6 or 8 experts all talking about what needs to be done, I send them these emails and say, so guys, where are we going with this? I haven't heard from any of you. I'm about to go and do this. Do you want to, there's legislation on Capitol Hill. Do you want to get involved? Are you really interested in moving ahead? So the points you make, I'm just saying, absolutely on the mark.
And what's really good, kind of like Edward's talking about, it's applicable in most industries. It's applicable in most of the different elements. And it's a fundamental different way than we approached it before. I love, though, not just having the apprenticeships, but actually building that into the curriculum.
Yes.
I have to give an example local that I thought was extremely good. A few years ago, the UT Austin started a new medical school, the first new one in the state in a long time. That's a research medical school. It's the Dell Medical School. What they did in their curriculum was very interesting, though. They required for all the doctors a programming class. And actually had the doctors writing code as part of their medical school experience. But what was even more important, I think, is they required a semester where they actually put the students out in the field and worked. It not only was great for the students, but it also helped elevate the skills of the people they were out in the field with. And I love the concept of apprenticeships. I love the concept of mentoring. And they're slightly different, but they go hand in hand. I also love the concept of co-op education. And particularly when you get to manufacturing, co-op education is a great way to put it. It's where industry might put equipment into a school. And say, this is one of the things I want you to teach on, and here's the pieces of equipment I want you to use. And again, there's many, many different approaches. What the key element, though, is you have to integrate where the manufacturing companies are going, where the science companies are going, where the support to the industry is going, and take those into account. I have to use one more example. Is when we formed Cimatech. Cimatech was made up of the 18 top semiconductor manufacturing companies. But we also formed something called Cimatech. And what Cimatech was over 200 of the suppliers to the semiconductor industry. Then we had the education We had education Cimatech, which was the human capital side. So we had to work both the mainstream technology, the mainstream manufacturing processes, but also the suppliers to that.
Mm-hmm.
Because I can put in a very advanced manufacturing facility, but my suppliers cannot support it.
Mm-hmm.
And you've got to look at it as the whole. And you have to model it as the whole, not just the plant. And you also, at that point, need to say, what is the life cycle?
Mm-hmm.
Is this a skill that will rapidly fall off? And understand when that fall off is, because from where that peak goes down, you have to go back some and say, this is where I have to start planning and producing the skills for the next generation of products. And again, it comes all to looking forward, understanding where you are, understanding where you've been, but you've got to understand the forward part, particularly in smart manufacturing.
Mm-hmm. Mm-hmm. Thank you. Thank you. Professor Edward, yes.
Well, I've got to agree with David on all of this. I don't, and what the lesson I think for emerging economies is keep all of these insights in mind. Some may not apply as directly at the moment, and again, because I've done work in with various emerging economies. And of course, emerging economies are very, very different, even in terms of location. If you go to Kuala Lumpur, or if you go to some of those places, they're fairly advanced. Then if you go out into the countryside where they need, they don't even have the infrastructure, maybe not even things like water and electricity that's reliable, or internet, as we discovered whenever we try to link up with some of our friends in Africa who I work with. You have this huge variation in levels of development within country. And so one of the things you can even think about is not only creating these hubs where education supports manufacturing, supports training, and so forth, but think about it regionally in terms of, it really doesn't make sense to have so many supporting industries, maybe very close in Kuala Lumpur or in Jakarta or whatever. Maybe this is an area where they can be out a little bit more, if not in the countryside where there's no electricity, at least in some areas that are not as, not as urban. But this would have the advantage of course, helping development in those other areas and making the system more efficient. Because you probably can, for example, do it depending on what the infrastructure is in the region. You can probably do some of the support, suppliers or support operations for less costs than if you're doing it in an urban area. Because if you go to Jakarta or Singapore or Kuala Lumpur or some of these places, you're going to find that the costs are much higher than if you go out a little ways. So, again, if I were a government, if I were, one of these governments thinking about this sort of development, I think in those terms, and not because you want the hubs, but you also want to allow for entrepreneurs to go out and put things into other areas. And again, this is going to help the entire country, think in a efficient business sense. And to me, and then they're going to be better globally, and that's going to be good for everybody.
Mm-hmm. Mm-hmm. Thank you. Yeah, Professor David.
And one thing to kind of build up this thing, think about the side benefit side. So one of the things my company is doing is we are installing a mesh network using free space optics, using millimeter band things to go to the rural environment of one of the poorest countries in this whole way over here. But what we're also doing is we're bringing internet out to this part of the country where even electricity isn't stable. We're bringing other things. So because we're going to have some of the mesh network internet there, we're building some plants there that will take the waste of the region, repurpose in a plant, a bio plant. It's going to generate power. It's going to generate fertilizer.
Mm-hmm. Mm-hmm.
It's going to help recover land out there that has been so neglected that it won't grow crops like it used to. Oh, guess what? This plant's going to also generate jobs.
Mm-hmm.
Oh, by putting that mesh network in, it's going to also generate jobs around the mesh network.
Mm-hmm.
One of the things we're doing is we're putting innovation labs. You can call it an incubator, call it an accelerator, call it an entrepreneur engine there, that some of the local folks there will begin to use that to be entrepreneurs, both within their local region and within the rest of the country. And because we're running the innovation lab in conjunction with the local people we're hiring there, we get to see those and say, can we transfer that technology and grow that company outside that country? And so it helps these developing areas become part of more the global economy, become part of more their national economy than just the local regions. But again, it's that whole element with the main effect, but then the other derivative effects from that. That makes a difference. And it really comes back to thinking larger as opposed to smaller.
Yeah. David, can I add one more thing? Because it's such an exciting thing. I know we have to sign off soon, but it's such an exciting discussion. The other positive externality, because I've followed these things for many decades, is the kind of citizens that are going to be created. As, for example, people in rural areas who are not in very good situations, learn that, first of all, they're efficacious. They say, wow, you know what? I'm not at the mercy of governments, or I'm not at the mercy of the elements, or whatever. I am, as an individual, efficacious. I can make a difference in my own life. That mindset is going to be absolutely crucial to creating a long-term, stable, open societies. And I don't think that should not be underestimated, because when I look at civil conflicts, when I look at, for example, unfortunately, what's going on in Nigeria right now, because I work with a lot of friends there, and I see part of it is that they never developed. A lot of people never developed that notion of a citizen who is part of the community. Where people deal with each other based on mutual consent, and that they feel personally efficacious, that they're in control of their own lives, and therefore they don't have to go out and fight another tribe, or they don't have to go out and fight another religion or whatever. So I think that that's crucial in the long term for stable systems in emerging countries. And we see some have done very well at this, some not so very well. So this is going to help. That's going to be a positive externality that I think everybody can agree with.
Thank you. Thank you, everyone, for joining today's session. This is really, really great session, and I'm sure this session will be very helpful for the Asian community, for the developing nations. So I request everyone, share our content as much as possible with your government, with your corporations, with your university and academia. I'm sure the Professor David, Professor Edwards, Professor Rob, they are the best in their place, and they can help us a lot to develop our community, to develop our manufacturing. And from my personal skills and knowledge, I can share one thing, that actually for developing nation, they have a lot of people, they have a lot of organizations, many different things still untouched. Still we have to do a lot of work. Millions and million people. From my personal experience, I help to grow a few group of companies, and I find that there are many things we can do, but we need proper collaboration. We need partnerships. We need partnership in between developed nations and developing nations. And I'm always lucky that I get very good support, like people like you, those who can change the community, those who can change the society. So hopefully in the future we will work together, World Talent Economy Forum, developing knowledge based community, and we are open for collaborations. So share our content, share as much as possible. So anything we can do, just share your concept, and hopefully we will implement. We are very fast for executions. So thank you, Professor David, for your excellent sessions, and Professor Edward, thank you for your continuous support for World Talent Economy Forum. Thank you. Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Thanks,
And take care.
Good show,
Bye-bye.
David.